Hi, today I'm going to show you how to use the CN70 sensor. These CN70 sensors are actually proximity sensors, but they can also detect black and white to some extent. And this is useful for making path tracing robots. This is actually not a CN70, this is a knockoff of a CN70 called CNY70. CNY70 is a cheap knockoff of the regular CN70. The regular CN70's price is, let me check. I just checked the prices online and the original CN70 is like $2 and the knockoff, which is called CNY70, is 50 cents. The difference between the original CN70 and the knockoff CNY70 is the fact that the CN70 can detect more colors. But for example, this CNY70 here cannot detect this marker on a paper, which confused me to like literally trash two sensors as I thought they weren't working while they were working, just not because they weren't detecting this marker as like black, they were detecting it as white, which is quite confusing, but the original one would probably detect this on a paper as black. So the differences between the original CN70 and the CNY70 is basically that, and its outer appearance is a little bit different too. The sensors, I don't know if I can get this well on camera. I'm gonna try to do my best to do so. I'm actually gonna just shine a light to the sensors. As you can see, the sensors, the individual pieces of the sensors are kind of protruding outwards. It's like bulging out, the sensor parts. But on the original CN70, they are completely flat. That is also a way to tell if it's a fake sensor or an original sensor. But the CNY70 can detect white and black as well. It can detect black tape, black electrical tape, and we can make arenas for line tracing robots with electrical tape on a white surface. So let me demonstrate how the CN70 works, but before that I'm gonna make a schematic for the CN70. So the CN70 actually is like a little square with indents on each side. My drawing skills aren't the best, but it'll do. So here are the two sensors, and it says CNY70. This is the marked part of the sensor, and let's just say pin out here. So this is, let me just draw the 4 pins of the sensor. This is the LED and this is the phototransistor, or the sensor itself. This is the plus voltage input of the sensor, and this is the signal out of the sensor. And this is the plus on the LED, the infrared LED built inside the sensor, and this is the minus. So how do we connect this to our circuits, you might ask? You can connect it to a breadboard like what I did by just bending its pins like this, but you can also put the sensor in a diagonal way. So if you put the sensor like so, let me just line up the pins. The pins are bent. This is annoying. Alright, so if we place the sensor here like so, yes, you can also place the sensor on the breadboard like this. The parts that you need to connect are bridged together. Like this plus rail is bridged together right now. This plus rail is, we're basically putting the sensor like this on the breadboard. You see? The breadboard has lines like this, like they're connected like so, individual lines, and we're basically shorting out these plus connections on the sensor. So we have one cable for the plus, and the other ones are the minus for the infrared LED and the signal out. But this is quite confusing to wire up, so I'm just gonna end up bending the wires of the sensor and just connecting it to the breadboard like I showed it to you. So I just bend the pins of the sensor a little bit. So I prefer putting the sensor on the breadboard like this, just by bending the pins of the sensor and putting it inside the breadboard like this, not putting it diagonally, which would short out the two pins, but this makes it a lot less confusing to wire up. So this is the LED side. The LED inside the sensor is the clear part. Let me see if I can show it to you. Yeah, you see there's like a bluish tinge on the top part, but the bottom LED part is clear. The bluish part is the photo transistor on this fake CNY70, and it changes between sensors. Like, some sensors have the bluish part as the LED and some have it the clear part as the photo transistor, basically vice versa of what we have here, which is quite confusing, and you kind of have to find out which one is the photo transistor and which one is the LED. You can do this by just attaching 3 volts or 2 AA batteries to 2 pins on like each side. Like, if you hold the sensor like this with the notches on the sides, there's 2 pins going to each component on the top and on the bottom, like so. So if you connect 3 volts here, and if you connect it properly, and you can see the infrared LED on the camera. You can connect it here and you can see it on the camera. If you connect it there, it's gonna be the photo transistor and you won't be able to see anything no matter which polarity you connect it in. So this is an easy way of testing which side is the LED and which side is the photo transistor, because this is important. Right here I have a 100 ohm resistor connected to the plus side of the LED. So this is 5 volts minus and plus, and I have a resistor that is 100 ohms, and we connect the negative side of course to the negative supply voltage like this, and we have to connect the positive side of the photo transistor to the positive of the power supply too. And the signal out also should be grounded or should be connected to a pull-down resistor of 10 kilo ohms. And this is where you get your measurement on this side. The signal out is here. If you measure it from here, you'll just measure the battery's minus connection, which wouldn't output anything. So you need to measure the sensor's output here. This grounding or pull down resistor is for interference, because the sensor may pick up some interference and this will negatively affect your measurements. This is why the 10 kilo ohm resistor is here. So the 100 ohm resistor is for the LED, of course. It shouldn't blow up. If you connect it to 5 volts directly, the LED will probably blow up. And let's actually demonstrate this. So as you can see, we have the circuit set up here, and I have this 6 volt adapter. It can output up to 6 volts even though it says 3 volts. 3 volts is when it's completely loaded to 600 milliamps, because it's just a transformer, and in this case it's going to be outputting around 5 volts with this regulator. So I'm just going to plug this in to a wall socket, and you can see the infrared LED lighting up on the CN70. And if I actually turn this off, you can see the LED going off. You see? That's it. If we get our multimeter here, set it to 20 volts, and I'm gonna measure this part, the signal out part, right here on the grounding pull down resistor's output, like so, the sensor's output, not the resistor's output, and I'm just gonna measure the plus part of the circuit. So we're getting 387 volts, around that mark, and I need to kind of put that wire like so. Yes, so 392 volts we're getting right now, and if I show a white tape, electric tape, you see it goes to almost 0 volts, 0.13. And if I show a black tape, black electrical tape, it goes around 3.5, 3.3, doesn't really change. So we can count this as high, and the sensor usually reads high when it's not reading anything. And if you show something black, it's basically measuring black, because the infrared light doesn't like get reflected from the black surface. It just doesn't reflect the infrared light, but the white tape does reflect it, and we're getting 0.14 volts. You see? But since the black tape doesn't reflect anything, we're getting 3.5. The measurement usually goes down to 0 volts because I'm not holding the other probe, I'm just putting a marker on top of it. But these are the only two things that the sensor can detect. Just white and just black tape. That's it. It cannot detect anything else that is black. I don't know why it does that. Let me actually demonstrate that with a marker. So I have this black marker, so I'm going to mark this paper with this marker, and I'm going to again measure the output voltage of the sensor. If I hold this here, as you can see, it detects it as white. What the heck? As I said, it only detects this black, this electrical tape black, for some reason. And for some reason this marker on the paper reflects the infrared light. And if I show a white part of the paper, it also shows 0.14 volts. Black shows 0.20, which is basically almost the same. If I show a white tape, 0.14, but if I show black tape, you see, it actually does detect it as black. 3.5, 3.6 volts. This is very strange, but this is one of the disadvantages of using a knockoff CNY70. And if we also use a brown tape, which should almost give us the highest voltage available, which is like 3.9 to 3.5, like with the black tape, how the black tape showed us the voltage. But if I measure it, it shows 0.74, so it also doesn't detect brown tape as black. So this is, as I said, one of the disadvantages of using a fake CNY70. It does not detect markers, and it does not detect any color that is close to black. It needs to be electrical tape black, which is very strange, but it does detect black. Only on electrical tape black. This actually caused me to believe two of the sensors on this robot that I was working on to be broken. So I bought two new sensors, and they did the same thing. Two new CNY70s. They did not register the black marker as black. They just registered it as white, which is very strange. And I thought the sensors were completely broken, so I just didn't deal with it until I just completely tried every single thing I had when it comes to black and white in the room, and only the black electric tape it detects. It's very strange, but it's one of the quirks of using a cheap and knockoff CNY70. So these sensors actually work, and the two sensors that I replaced and trashed were actually working, and I thought they weren't. But yeah, that's just an experience, let's say. But if we measure the thing again, we have 5 volts on the input of the CNY70, and it shows us almost 4 volts while not measuring anything. and it shows us around 3.5 while showing it black, which should be like around 5 volts, and on white it shows us 0.15 to 0.14. So these signals, as you might understand, are not digital, they're analog signals, and they change a lot. And you can use this with Arduino, but it's gonna be a really complicated code. Like, you have to make like certain measurements really correct to read it off of an Arduino's analog pin. You can technically do it, but the coding is gonna be way more difficult. To make it a lot less difficult, we have a chip called SN74HC14, and it is this chip right here. And I'm actually gonna steal this chip from this robot for a second. Good thing I made this chip socketable. So this is just a inverter chip that has 14 pins, and what it does is regulates the voltage to 0 volts and 5 volts. That's what it does. If it has 3.5 volts on the input, it turns it into 0. If it has 0.14, 0.15, 1 volt, 0.7 volts on the input, it turns it into 5. It does that because it also has an inverter chip inside, but it has multiple inverter chips inside. And if we actually search up SN74HC14 on Google, we can get circuit diagrams and schematics of this chip. And right here, this is what the internals of this chip is. It has 6 different inverters inside that also regulate the voltage. So if you input a signal in this inverter, it inverts it and spits it out of this pin. And it's inverted, but if you want to have the original signal completely regulated and not inverted, you can put the inverted signal onto another inverter and invert it to the original signal's volume. Like, it inverts the 0 volts to 5 volts and 5 volts to 0 volts first, but if you do that again, it's gonna be the same signal as it enters, and it's gonna be really nicely filtered out. Like, it's not gonna be analog, it's gonna be completely digital. And this is the only purpose of this chip. You can use like up to 6 sensors with this chip if you're not going to use 2 inverter channels to make the inverted voltage the same as the supply signal. So you can use, as I said, up to 6 sensors with this, and if you need to like use the exact same, like 5 volts to 5 volts, 0 volts to 0 volts, you can use 2 inverter channels per sensor, and you can use 3 sensors if you do that. So if we go back here, I'm just going to put this on the breadboard, and I'm going to just grab some jumper wires. Give me a second. So okay, I'm back with some jumper wires to wire up this circuit. I'm only going to demonstrate one sensor right here, because you can just add different sensors to the different channels of the SN74HC14. It's just like the same procedure as I'm doing right here. You can apply the same procedure to the other sensors too. So I'm just going to connect up the VCC, which is the 14th pin of the chip, to 5 volts here. This is the power pin plus power pin of the chip. Let me just route it a little bit better, and let me actually power it off first. And the 7th pin on the opposite side is the ground, so I'm gonna put this to ground. So we have our signal out. I'm actually gonna get our signal out right here, and I'm going to put it through an inverter channel. And if I put another jumper wire next to the inverter's output right here, this is our new signal output. So if I power up the circuit, you can see it's still shining. Our signal is now inverted and it's been regulated too. So if I measure it here, so this is our new signal, and we're getting almost 0 volts. Yes, we're getting 0 volts, as you can see. And if I show white, as you can see, almost 4 volts. This also might be because the voltage step down chip is only outputting 4 volts right now, but it isn't very important. As you can see, when I show white, it's outputting 3.93, which is almost 4 volts. And it was outputting 0 volts while I was showing the white tape, so it just inverted it. And if I show the black tape, it stays at 0. If I show the brown tape, it shows us 4 volts. If I show the marker that it detects as white, it says almost 4 volts, because it detects it as white, and yep, almost 4 volts. But what if we want the original signals, like 5 volts to 5 volts, 0 volts to 0 volts, not inverted? We can basically just put the inverted signal to another invert channel right here. I'm gonna put it on the second channel to invert the first inverted channel, and then get the output from the second channel, like so. So this is our new output, which should be the same as what we started with. Yep, almost 4 volts. And if I show black, still, let me just put this right here, still 4 volts. And if I show white, 0 volts. Look at that. Brown tape, 0 volts. Marker that detects as white, also 0 volts. You see? So you can basically use the SN74HC14 this easy. It's very easy. It's not complicated at all. And that's it. That's about it. I'm also going to give you a fun fact about phone cameras. While the human eye can't see this infrared light, most Android phone cameras can see this light. Except iPhones can't also see this light, so you will need another camera or an Android phone to view this light if you have an iPhone. So this is how to use the CNY70 and SN74HC14. If you liked my video and found it useful, please don't forget to like and subscribe to my channel, and if you share my videos with your friends that tinker with electronics, it would really help my channel. Thank you for watching, and see you on a new project.